What is up, everybody? We are into 10.3, area of circles and sectors. So far we talked about area of parallelogram, area of triangle, area of trapezoid, area of rhombus, area of kite. We are now going to get into area of circles, and I'm going to introduce you to sectors. So let's get into this, okay? So remember, a circle, right, has a radius of r, and we know that the circumference, the distance around the circle, is 2 pi r, or pi times the diameter. All right. Then when we draw in another radius from the center, we create an arc. Okay, so we have arc BC, and we have central angle x. We know that a central angle is equal to the arc that it creates. Then, when we were talking about arc length, and remember, so the actual distance from B to C, not the measure, but the distance, it was the arc measure of the length we were trying to find over 360 equals arc length over circumference. And the reason this formula works, remember, is each ratio is the same percentage of the entire circle, right? So arc measure is a certain percentage of 360 because 360 is the entire arc measure. And then arc length of BC is a certain percentage of the entire circumference. And that percentage is equal in both of those ratios, and that's why we can make these equations equal. Okay? So, we also know that an area of a circle is pi r squared. Okay, so that's one of our formulas that's like maybe something new. If you didn't know that, the area of a circle is just pi times the radius squared. All right, and so we'll do a couple examples where we actually use that at the end. But the main new thing, actually, let me rewind that really quickly. So guys, to find the area of a circle, all you need is either the radius or the diameter. It's a very simple formula. If I'm given the radius, I just plug it in. If I'm given the diameter, I divide it by 2. Okay? Sorry about that, guys. There might have been like a weird little pause in my recording, but it got cut off. We're good. So again, if I'm given the diameter, then I just divide that by 2, and then I have my radius. Because remember, diameter is half the radius. Okay? So, sector of a circle. All right, that's kind of the new big thing for today. The sector of a circle is like a piece of pie or a piece of pizza. All right, it's a certain portion of the circle. So, a sector is an area of a circle bound by a central angle. So this right here in yellow, that is a sector, or what I have here in orange. Okay. Now, that sector of the circle, right, has a specific piece of the area of a circle. Just how if I were to cut a piece of pizza into 8 even slices, one piece of pizza would be 1/8 of the area of that circle. If I cut it into quarters or fourths, one piece of pizza pulled out would be 1/4 the area of that circle. Okay? And so notice that a sector still has a central angle, still has an arc measure. All right? And so the key thing to understand here is that that piece has the same relationship to the arc measure and the arc length, in that it's the same percentage of the circle that the arc measure is of the 360, that the arc length is of the circumference, but now it's just the same percentage of the area. So the area of the sector is proportional to arc measure, just like arc length. So we actually are going to be reusing this part of our equation to be able to find the area of a sector. So A equals the area of a sector for this formula. Okay, we have A equals pi over r squared. So A is the area of the sector. Pi r squared is the area of the entire circle. X is the arc measure of the sector. And then it's obviously over 360 because 360 is the entire arc measure of our circle. So again, it's using the same principle, the same idea, that each one of these ratios as a percentage is covering the same amount of the total circle. And that's the big idea to understand, right? So remember, like I said, if I were to take a pizza and cut it up into 8 even slices, each crust would have the same arc measure, right? Or the same arc length of the entire circumference or the entire 360 of a circle, which means that each piece of pizza would be the same percentage of the actual entire pizza, 1/8. Okay? So that is our big new equation for the day. That is the equation for area of a circle, but it's the area of a sector of a circle. But it's important to understand that A represents area of the sector that you're looking at. Pi r squared is our total area of our circle. X is the arc measure of the sector you're looking at, and then 360 is our constant. So now let's jump into a couple examples. Okay, so just a couple of quick examples of area of a circle. So let's find the area of each circle. So our radius is 1.5. So remember, area equals pi r squared. So our area is going to be, for pi we use 3.14 times our radius squared. So 1.5 squared is 2.25. Multiply that by 3.14. So our area is 7.1 meters squared. Number 2, it's 24 inches, so that means our radius is 12. So area equals pi r squared. Well, we know that 12 squared is 144, so 144 times 3.14 gets us 452.2 inches squared. Okay. And then 4 through 5 are just some questions that are involving algebra. So it says the area of a circle is 3.14 square centimeters. Find the diameter. So if area equals 3.14, and we know our area formula is pi r squared, and they're asking for the diameter, we have to solve for r, all right, because we know what a is. So it'd be 3.14 equals pi r squared. Because remember, pi is not a variable. Well, pi is 3.14, so when we do this, there's still a 1 left over. So that means our radius is 1, which means our diameter, because the square root of 1 is 1, would be 2. Okay. Then if let's do number 7, it says find the radius of a circle with an area of 2,290.2 square feet. So 2,290.2 equals pi r squared. I'm going to divide by 3.14. So 2,290.2 divided by 3.14. My calculator is dying. Sorry about that. Let me get a different one. So again, 2,290.2 divided by 3.14. It gets me 729.4 equals r squared. Then all I'm going to do is I'm going to take the square root of that number, and I get 27. So my radius of a circle with area 2,290.2 is 27. So just some simple area problems right there. Okay, let's now jump into area of our sectors. All right, so here we go. So it says find the area of each shaded region, round to the nearest tenth. Okay, so we are trying to find the area of this sector right here. So the information that they're giving us is that the central angle of this sector is 37 and that the radius of this circle is 19. So let's quickly just rewrite down what our formula is. It's area of our sector over the area of a circle equals arc measure of our sector over 360. Okay, so that would become A over pi r squared equals arc measure, which is 37, over 360. Okay. So now what we're going to do here is we're going to cross multiply. So I can do 360 times A, that gets me 360A, equals, I'm going to do this all in the calculator at one time. Actually, I'll show it. So I'm going to do pi times 19 squared times 37. And again, you can kind of do this, you can string this together all in your calculator. So I'm going to do 19 squared first, and I'm going to that gets me 361. I'm going to multiply that by 3.14. That gets me 1,133.54. I'm going to multiply that by 37. Big number. So I'm going to get 41,940.98. Again, that's still equal to 360A. Then I'm going to take that number, divide it by 360 to get the A by itself. So A becomes 116.5 meters squared. Done. Okay. Looking at number 9. So they're telling us the central angle of the non-shaded part is 8, which means our central angle or our arc measure of the shaded is 360 minus 8. So that would be 252. Okay. Our radius is 6, so area of the sector over area of the circle equals arc measure 352 over 360. Cross multiply, I get 360A equals, I'm going to be multiplying all this stuff together. So 6 squared is 36. 36 times 3.14 is 113.04 times 352 gets me 39,790.08. Divide that by 360. I get 110.5 inches. All right. And then let's go ahead and do our last one, number 10. Well, let's just do setup at least. So it says our arc measure is 128 because our central angle is 128. So we have area of our sector over area of our circle equals arc measure of our sector over 360. Okay, that would then become 360A equals, cross multiply all that stuff, so 10 squared is 100, 100 times 3.14 is 314, 314 times 128 is 40,192, divide that by 360, our area is 111.6 centimeters squared. Okay, so not too complicated, not too bad. And then guys, for this last problem, it just says, what is the area of the shaded region? So notice you have a circle inscribed a square. So to find the area of the shaded region, which is only this, the corners of our square, it's going to be area of square minus area of circle. Okay, so notice, right, our square is 18 by 18, so that would get us our area. Our circle, if you think about it, if I were to draw a radius straight down, I can draw one, or straight up, either or to the side, right? Because remember, the center of that circle would be at the center of the square, so that means the radius is going to be half the length of the side length of that square. So that is how you would do a problem kind of like that. And we're all done. Good luck.